For thousands of years, humans have invented ways to propel themselves through water. But long before humans invented their propulsion systems, nature developed its own methods of moving through liquid space, not only in fish and other large aquatic creatures, but in organisms so tiny they cannot be seen by the naked eye. Perhaps the most amazing propulsion system on our entire planet is one that exists in bacteria. It's called the flagellum, a miniature propeller driven by a motor with many distinct mechanical parts, each made of proteins. The flagellum's motor resembles a human-designed rotary engine. It has a universal joint, bushings, a stator, and a rotor. It has a drive shaft and even its own clutch and braking system. In some bacteria, the flagellar motor has been clocked at 100,000 revolutions per minute. The motor is bidirectional and can shift from forward to reverse almost instantaneously. Some scientists suggest it operates at near 100% energy efficiency. All of this is done on a microscopic scale that is hard to imagine. The diameter of the flagellar motor is no more than 5 millionths of a centimeter. The bacterial flagellum is one of many molecular machines that scientists have discovered in the last several decades, including energy-producing turbines, information copying machines, and even robotic walking motors. The origin of these exquisite examples of nanotechnology is a mystery that has generated heated controversy among biologists over the past 2 decades. And it's a mystery that has transformed one man into a scientific rebel, willing to challenge one of the most cherished ideas of the scientific establishment. Biologist Michael Behe is an unlikely figure for a revolutionary.
I never was interested in stirring up the pot just for fun. I'm basically shy. I, don't like to give anybody unnecessary trouble.
A mild-mannered professor at Lehigh University, Behe received his PhD in biochemistry from the University of Pennsylvania, one of America's top research universities. He spent his early career as a member of the scientific establishment, publishing peer-reviewed articles in science journals and receiving research funding from the National Science Foundation and the National Institutes of Health. But by the early 1990s, Behe was toying with heresy.
Another aspect of my personality is that I'm stubborn. If I see something and I mention it and nobody has a good reason that they can answer me with, I'll stick with it. And especially in this area. I'm a scientist. I'm supposed to want to know how biochemical systems came to be.
Behe found himself with growing doubts about one of the central tenets of modern biology, Darwinian evolution. According to the modern version of Darwin's theory, known as Neo-Darwinism, even the most complicated biological features originated through a process of natural selection, sifting through random mutations or copying errors in the genetic instructions stored in DNA. For example, a random genetic mutation might give a particular bird a slightly longer beak. This small change could help the bird survive better, and eventually its offspring with longer beaks would come to dominate the population. A longer beak size might not seem all that important, But Darwinian theory asserts that over time, many similar unintended changes could accumulate, ultimately producing an organism radically different from its original ancestor. According to neo-Darwinism, new species and new biological features do not develop according to an intelligent plan. Instead, they arose from the accumulation of thousands of small, undirected genetic mistakes over millions of years. The more Michael Behe studied the staggering complexity of life at the biochemical level, the harder he found it to believe the standard Darwinian story. The bacterial flagellum was one of the biochemical systems that fueled Behe's skepticism.
The bacterial flagellum is literally an outboard motor that bacteria use to swim. It uses a little piece that spins round and around and round and pushes against the water just like a propeller does in an ordinary outboard motor on a boat in our everyday world. And the propeller is attached to a drive shaft, which is attached to a motor, which has clamps holding it in place, and dozens of pieces that are required for it to do its job. It's just a fantastic example of what science has discovered, and that is molecular machines.
The first time Behe saw a diagram of the flagellum, he was captivated.
I looked at it and says, wow, that's really fascinating. I wonder how that evolved. And then I'd turn the page and say, go on, do something else. And any skepticism was defeated by assuming that somebody must know this, because everybody says Darwin's theory is true.
But then Behe read a book by geneticist Michael Denton. Denton argued that Darwinian theory was in crisis because its mechanism of random mutation and natural selection wasn't capable of producing major biological innovations. After reading Denton, Behe's doubts about the origin of molecular machines like the flagellum grew.
Then I went back and said, well, who does know how this could have evolved? And nobody had anything to say about it. Even hand-waving speculations were hard to find.
Behe began to dig deeper to find an answer.
Darwin's theory says you have to start with something that's working a little bit, and then it will change, mutate a bit, and that helps a little bit, and that'll be selected, and then improve a little bit more and a little bit more until you get the full-fledged system. And I said, well, it does not look like some of these systems can be done that way, because they need all of these parts. You know, if you don't have this one, it's not going to work. You can't take any of the parts away. I was kind of sitting at my desk scratching my head. You know, you can't take the parts away. You can't reduce it at all. It's irreducible, and so it's irreducibly complex. I thought, bingo, that encapsulates the problem for Darwin's theory right there.
Behe decided to write a book explaining his heretical ideas. Published during the summer of 1996, Darwin's Black Box quickly attracted attention. Darwin's supporters had insisted that there were no credible scientific objections to Darwin's theory. But now a scientist at a mainstream American university was saying otherwise.
My editor called from Free Press, and he says, okay, the book's going to be out at the beginning of August, and the New York Times is going to do a review, you know, the week before.
It was reviewed everywhere. The New York Times, National Review, Nature, technical science journals, popular publications. The term itself, irreducible complexity, entered the lexicon where it's still very alive. It's become part of the scientific descriptive toolkit, if you will.
At that point, I realized that, you know, I had gotten into something I had not anticipated. It got a lot more discussion than I had ever dreamed about.
The bacterial flagellum was one of the central examples of irreducible complexity Behe highlighted in his book.
If you take away the propeller, if you take away the motor, if you take away the clamps that hold it onto the cell's membrane, take away any of a number of different parts, it's not that the flagellum is going to spin half as fast as it used to, or a quarter. It's broken. It doesn't work at all. It's like taking the propeller off of of an outboard motor on your boat and wondering how far now you can go in the water. You can't go anywhere. So that's a problem for Darwin's theory, because Darwin's theory says that things evolve by working a little bit, maybe not very well, but a little bit, and then a mutation, a change comes along that helps it work a little bit better, and that helps the organism survive and have more offspring. And so then another change comes along, and another, and it gradually builds up to the final structure. Well, that might work for some things, but it doesn't work for systems that are irreducibly complex, things like the bacterial flagellum. Because, well, if you wanted to build an outboard motor for a boat, what would you start with? Would you start with, say, just an iron rod that, in the future would attach a motor to the propeller? Well, what's that going to do? It's not going to do anything. Would you start with just the propeller? Well, that's not going to do anything. It's not attached to anything. Would you start with just the motor? Well, that's not going to propel you anywhere. So with irreducibly complex systems like the flagellum, Darwin's idea is dead in the water, like a boat with an outboard motor that doesn't work.
Natural selection selects or favors in variations that confer a functional advantage on a system. Many of the simpler versions that you could imagine of the bacterial flagellar motor perform no function at all. And so if you imagine trying to build a flagellar motor, adding parts one by one until you finally get to the complete system, you're going to encounter configurations of parts that confer no function, in which the motor simply will not work, at which point the evolutionary process will terminate. It will cease to continue because the system conferring no function will not be preserved and passed on to the next generation.
Behe didn't just challenge the Darwinian explanation for the flagellum in his book, he also offered a controversial alternative explanation, proposing that the flagellum was produced by intelligent design. The flagellar motor and other molecular machines certainly look as if they had been designed by an intelligent engineer. But Darwin and his modern followers claim that the unguided mechanism of natural selection and random variation could mimic the powers of a designing intelligence, giving rise to the illusion of design in nature. Yet, according to Behe, scientists had now discovered irreducibly complex systems in biology that could not be explained by Darwin's mechanism. Perhaps, Behe reasoned, the appearance of design was not an illusion after all.
The question is, how do we recognize design? How do we realize that something has been put together, intended by an intelligent agent? Probably the only real way that you can do it without taking somebody's word for it that they have put something together is by recognizing what's called a purposeful arrangement of parts. Think of, say, Mount Rushmore. You look at the rocks to the left of the images of the presidents, and they don't look like much of anything. And you look at the images, the rocks that are in the shape of the images, and you immediately realize that it was designed. Even somebody who had never heard of Mount Rushmore before from another country would immediately realize that it was designed. And the question is why? Well, because the shape of the rocks are matched to each other. They're ordered, they're put together for a purpose, and the purpose is to portray the image of the presidents. We humans are good at recognizing design. If you go down the street and you see some neighbor's yard that has dandelions around it, and you say, that guy, he should really take better care of his yard. Then you look to the right and you see a patch of tulips, nicely cultivated next to the mailbox or something. You immediately know that the tulips were intentionally put there. Not to get all philosophical here, but if you ask yourself, how do you know you're not the only intelligent being in the universe? It's because you see other people doing intelligent things, like arranging words so that they make sense into books and so on, or arranging paint into paintings, or arranging pieces into machines, or doing intentional activities. It's a very deep part of our own minds, our own intelligence, that we can recognize the effects of the intelligence of other beings in the purposeful arrangement of parts.
Whenever we see tightly functionally integrated systems, we know of only one cause that has produced those features, and that cause is intelligence. That's what we know from experience. And so when we see a feature like that in living systems, given that there's only one known cause of what Behe calls irreducible complexity or functional integration of parts, and that causes intelligence, I think we can reasonably infer that that same kind of cause was at work in the origin of that system in biological systems, and therefore intelligent design isn't just an argument from ignorance, it's an argument based on what we know about the cause and effect structure of the world, that only intelligence generates irreducible complexity or tight functional integration of parts, and that's what we see in living systems. Therefore, living systems were produced by designing intelligence.
Even more than Behe's critique of Darwinian theory, his proposal that biological marvels like the flagellum pointed to intelligent design provoked a backlash. Critics accused Behe of pushing religion, not science. Although he is a committed Roman Catholic, Behe explained he had never had any theological objection to evolution, and he pointed out that his inference to design was based on empirical observations and scientific reasoning, not faith. Behe also made clear that although he believed in God, he didn't think the evidence of design in biology was enough to identify the designer on its own. All it could do was establish whether something was the product of intelligence. Over the next several years, supporters of Darwin's theory aggressively tried to refute Behe's arguments.
And any, quote, argument or evidence against evolution that overlooks the fact that parts of this system have functions on their own is certainly not going to cut it.
Their efforts ultimately culminated not in the lab, but in a courtroom in a high-profile legal battle. Behe would soon find himself and his ideas on trial. Today, the small town of Dover in southeastern Pennsylvania looks peaceful. But in 2004, it became the battleground for a bitter conflict that attracted attention from around the world. The conflict arose after the Dover Area School District required the reading of a short statement about evolution in high school biology classes. The statement told students that Darwin's theory had gaps and continues to be tested as new evidence is discovered. It further announced that there was a view that differed from Darwin's theory called intelligent design, and if students wanted to learn more about it, they could read a book that had been placed in the school library. The statement concluded by encouraging students to keep an open mind when it came to any scientific theory. On its face, the Dover statement did not seem to be the stuff that epic battles are made of. Supporters of Darwin's theory, however, were furious. They insisted that reading the statement was equivalent to the state endorsing religion. Ironically, many supporters of intelligent design also opposed the Dover policy, including Discovery Institute, the nonprofit think tank with whom many pro-intelligent design scientists were affiliated.
Discovery Institute actually opposed what the Dover School District wanted to do about intelligent design, and we asked them to repeal their policy because we didn't want intelligent design to become a political football.
The ACLU eventually filed suit, alleging that the Dover policy was unconstitutional.
This board acted with a clear and unconstitutional purpose.
The case was assigned to Federal District Court Judge John Jones. A former trial lawyer and head of the state's Liquor Control Board, Jones had a long career in party politics. Most judges try to stay out of the limelight, but Judge Jones made himself readily available for media interviews. He even speculated about a future film version of the trial, telling reporters he hoped Hollywood star Tom Hanks would play him on the big screen. At the same time, Judge Jones expressed interest in an earlier movie.
Man did not evolve from the ape, but the ape evolved from man.
Judge Jones told one reporter he planned to watch the 1960 film Inherit the Wind to supply him with historical context for the case. Inherit the Wind was a highly fictionalized account of the Scopes monkey trial of the 1920s, where high school teacher John Scopes was prosecuted for violating a Tennessee law banning the teaching of human evolution. Historians have argued that Inherit the Wind reduced history to blatant stereotypes, portraying the debate over Darwin's theory as a stick-figure battle between bigoted fundamentalists and open-minded scientists. It was a strange film to watch for someone who is supposed to be impartial. The key legal issue presented in the Dover case was the limited question of whether the school board acted with a non-religious purpose. But lawyers on both sides wanted to expand the focus to place intelligent design itself on trial.
Intelligent design is not science.
Intelligent design is just creationism in its new name.
Living a little more than 100 miles away from Dover, Michael Behe had mixed feelings about the case. He was interested in science, not politics, but the ACLU was trying to place his scientific argument for intelligent design on trial. So Behe agreed, reluctantly, to serve as an expert witness in order to defend his ideas. The bacterial flagellum soon became the trial's poster child as ACLU attorneys tried to undermine Behe's credibility. Their first expert witness was Brown University biologist Kenneth Miller.
I don't think it's a valid scientific theory. I don't think it's good education, and I don't think it has any place in the classrooms in Dover.
Miller challenged Behe's claims about the flagellum head-on. He explained that molecular machines like the flagellum could have been built by natural selection from pre-existing components that originally had different functions. Miller then announced to the court that he had developed a test that would conclusively prove whether the flagellum was irreducibly complex.
Dr. Behe's prediction is that the parts of any irreducibly complex system should have no useful function. Therefore, we ought to be able to take the bacterial flagellum, break its parts down, and discover that none of the parts are good for anything, except when they're all assembled in a flagellum. If Dr. Behe is correct, if we take away even one part, there should be no function.
The flagellum is built out of proteins, and for his test, Miller said he would propose taking away not just 1 or 2 proteins from the flagellum, but 30. If Behe were right, surely taking away so many parts of the flagellum should leave it completely non-functional. Miller then dropped his bombshell. When the 30 proteins are removed, the remaining 10 proteins are not without function. Instead, they reveal something called the type 3 secretion system. In some other bacteria, this secretion system forms a simpler needle complex, a molecular syringe used to inject toxins into a host organism. For Miller, the type 3 secretion system needle complex supplied a definitive refutation of Behe's claims about the flagellum. It showed that evolution could have built the flagellum by co-opting a pre-existing simpler system.
What that means in ordinary scientific terms is that the argument that Dr. Behe made is falsified. It's wrong. It's time to go back to the drawing board.
9 days later, Behe himself took the stand and offered a detailed refutation of Miller's claims. Behe argued that Miller had misrepresented his idea of irreducible complexity. Behe did not claim that when one part of an irreducibly complex system is removed, the remaining parts could have no function. Instead, he argued that when one part is removed, the system as a whole no longer functions. In the case of the flagellum, if you take away one of its key parts, the system doesn't operate at all as a propulsion system. As for Miller's proposal that the flagellar motor could have evolved from pre-existing parts with other functions, Behe responded that this scenario, while logically possible, was highly improbable. It relied on the assumption that natural selection could co-opt existing parts and redeploy them to create the flagellum motor.
There are some examples where I think such a thing can happen, but that's not going to help in irreducibly complex systems like, again, the flagellum. Suppose you said, I want to build a mousetrap, and I'll go into the garage and try to co-opt some old things that I find there for use in the new mousetrap. And you see that a mousetrap needs a spring, and in your garage you have an old clock. So you pull out a spring from that. And you see that the mousetrap has a metal bar, and you've got a crowbar in your garage. And you see that it's got another metal piece, the hammer, and you've got, the fender of a bicycle. Well, you can't make a mousetrap from all those pieces because they have been fit for their other roles, and they will not work as pieces of mousetrap unless they are extensively reworked or refitted, and that, of course, is intelligent design. Even under a Darwinian view, you would not expect pieces to be laying around that would be fit for roles in other complex systems, because you would expect natural selection to shape them very tightly to the role that they are currently fulfilling. And so to be used for something else, they would have to be reshaped, retooled before being used, and then you have the problem with irreducible complexity all over again.
But what about Miller's bombshell, the type 3 secretion needle complex? Didn't that prove that the flagellum had evolved from a simpler structure through undirected natural selection? Behe had a surprise of his own. He pointed out that a number of evolutionary biologists actually thought the needle complex had evolved after the flagellum. And if the needle complex arose after the flagellum, there is no way it could have been used by the evolutionary process to build the flagellum. In fact, it was possible that the needle complex actually devolved from the flagellum.
But if that's the case, that doesn't help Darwinian evolution at all, because having a fantastic machine which degrades to give a simpler machine is not an impressive example of the power of Darwinian evolution. That might be compatible with intelligent design. It's certainly incompatible with Darwin's theory, or at least it doesn't help it at all.
But there was an even more fundamental problem with Miller's hypothesis, according to Behe. Even if the needle complex had existed before the flagellum, that fact alone did nothing to show how it could have been transformed into the flagellum by natural selection acting on random genetic changes. It's not enough for advocates of co-option to identify a single possible intermediate structure. Instead, they must show that a series of intermediate structures existed that could have maintained some function at each stage in the evolutionary process. But in the case of the bacterial flagellum, experimental evidence casts doubt on that idea.
We know from genetic knockout experiments that the 29-part, the 28-part, the 27-part, the 26-part version of that machine simply will not function. It will not work as a rotary engine. And so building up through those stages of non-function is not going to happen, because there's nothing there that will confer a functional advantage on an organism that will then be passed on to the next generation. And therefore, the evolutionary process will terminate when it encounters one of those non-functional thresholds in this alleged sequence from something simpler to the flagellar motor.
In the final days of the trial, Behe's testimony was backed up by another biologist named Scott Minnick. A microbiology professor at the University of Idaho, Minnick had conducted lab research on the flagellum. The year before, Minnick had come out in the scientific community as a supporter of intelligent design. He co-authored a paper for a scientific conference with philosopher of science Stephen Meyer. In the paper, Minnick and Meyer argued that the flagellum was best explained by intelligent design. As Minnick told the court, his decision to submit the paper had been a difficult one. At the time, he was in Iraq as a member of the Iraq Survey Group, searching for biological and chemical weapons for the U.S. government.
Things had begun to deteriorate in terms of the military situation at that time. We had a deadline to get this paper submitted. It was looking at the flagellum as an argument for irreducible complexity and intelligent design. Steve had made his final edits. I had made mine. I was in the top of the Perfume Palace in one of Saddam's complexes near the airport. this large dome structure up on the top floor. And the deadline was midnight in London to get this paper in to participate. And I was hesitating, do I really want to do this? What are the consequences? Am I going to lose my job? Am I going to be able to support my family? I was alone up there with one other young military, I think it was a corporal. And just then a mortar round went off. I estimated that it was about 300 meters away. That catches your attention. I mean, it's a pretty loud explosion. But then another one came in a few seconds later, and this one was much closer, probably about 200 meters we were estimating. And then another one came in. Whoever it was were walking these rounds right towards, the Perfume Palace. And so then I said, well, I may not be here tomorrow. Boom, I hit the send button and it was done.
Minnick's decision to testify at Dover proved to be personally costly.
There were people in my university, I don't know who they were, but they went to the president, complained. They went to the University of Washington, where I had affiliate status because I teach medical students through the University of Washington system in Idaho, trying to get me fired, saying I was incompetent if I believed in this stuff. Nobody asked me ever what I believed. I never taught this in the classroom, but I ended up getting censored.
On the witness stand, Minnick reiterated the evidence that the type 3 secretion needle complex had developed after the flagellum. He also challenged co-option scenarios as highly speculative and biologically implausible. But in the end, it didn't matter. A few days before Christmas, Judge Jones issued his ruling. He didn't just strike down the Dover school policy as unconstitutional. In a blistering 6,000-plus word critique, he also concluded that intelligent design was not science.
Thank you, Judge Jones. This is an absolutely thrilling decision.
Many scientists and the news media lavished praise on the judge. Time magazine featured him on its cover as one of the world's most influential people in the category of scientists and thinkers. PBS later staged an elaborate reenactment of the trial for its documentary titled Judgment Day: Intelligent Design on Trial. The documentary showcased the type 3 secretion needle complex, which was depicted as devastating evidence against Behe's argument for intelligent design. Behe and Minnick's detailed responses at the trial were conveniently left out. For many people, certainly those in the media, the case for intelligent design of the flagellum now appeared dead, killed by an impartial federal judge. It didn't take long for that assessment to begin to unravel.
Science is not decided by judges. A number of legal scholars who don't like intelligent design criticize Judge Jones for actually going way beyond the legal questions.
The part of Kitzmiller that finds intelligent design not to be science is unnecessary, unconvincing, not particularly suited to the judicial role, and even perhaps dangerous to both science and to freedom of religion. Professor J. Wexler, Boston University School of Law.
More questions were raised when critics did a detailed analysis of Judge Jones' critique of intelligent design and made an astonishing discovery.
More than 90% of Judge Jones' analysis of intelligent design was basically cut and pasted from legal documents given to him by lawyers working with the ACLU, right down to the factual errors in their briefs. So when they would misquote someone like biochemist Michael Behe, he would misquote Michael Behe with the same misquote because he didn't even bother to go back to the record to re-verify the quotes. He just cut and pasted.
But perhaps the most revealing development involved the bacterial flagellum. During the trial, attorneys challenging the school district confidently assured Judge Jones that the flagellum was easy to explain in Darwinian terms. However, just a year later, one of the scientists who had advised the ACLU in the case co-authored an article in a science journal that made a startling admission. Attempting again to refute Behe's ideas, the article conceded that the flagellar research community has scarcely begun to consider how these systems have evolved. In the years after Dover, it became clear that the answers offered by Darwin's supporters during the trial were not enough to silence questions being raised by scientists like Behe. The controversy over new scientific challenges to Darwin was continuing to spread, not only in America, but around the world. And Michael Behe and the bacterial flagellum were still playing starring roles, as a major scientific exhibition in Europe was about to show. In 2009 marked the bicentennial of Darwin's birth and the 150th anniversary of his landmark book On the Origin of Species. Around the globe, supporters of Darwin planned a year-long celebration. In Germany, one of the largest Darwin anniversary events took place in the city of Stuttgart at its State Museum of Natural History. The exhibition was directed by German paleontologist Günter Beckley, one of the museum's curators.
We had about 100,000 visitors, and the complete exhibition, together with a program that was accompanying this exhibition, was one of the largest, if not the largest event in the course of the Darwin Year celebrations in Germany.
Beckley decided to use the exhibition not just to celebrate Darwin's theory, but to make clear to the public that there was no debate about Darwin's ideas among scientists. In order to refute the growing idea of intelligent design, Beckley decided to include a display on the bacterial flagellum.
The reason why we selected the flagellum as the poster child to basically expose intelligent design was that the bacterial flagellum has a kind of iconic status. We built a mobile model of the bacterial flagellum and had this animation to show that it could originate naturalistically.
The exhibit highlighted the type 3 secretion needle complex as an explanation for how the flagellum could have evolved. In addition to an exhibit about the flagellum, Beckley came up with a display to dramatize for visitors the overwhelming scientific evidence for Darwin's theory. It was a balance with books on it.
And the plan was, on one side of the balance, we would have all the books against evolution, books by creationists, intelligent design proponents. And on the other side of the balance, we would have one book, The Origin of Species, but the balance goes down on the side of the one book because this is the real heavy evidence.
But the display didn't have quite the result Beckley intended.
And I made one big mistake. I read the books on the lightweighted side, the apparent lightweighted side. And what I recognized to my surprise is that the arguments I found in those books were totally different from what I heard either from colleagues or when you watch YouTube videos where the discussion is around intelligent design versus neo-Darwinian evolution. And I had the impression on one side that those people are mistreated, their position is misrepresented, and on the other hand that these arguments are not really receiving an appropriate response and they have merit.
One of the books Beckley read was Darwin's Black Box.
I read Darwin's Black Box, where he basically introduces this concept of irreducible complexity.
Beckley soon realized that proposed Darwinian explanations for the origin of the flagellum didn't work. The type 3 secretion needle complex was no help because it probably developed after the flagellum.
This is a reduced flagellum motor and not a precursor of a flagellum motor.
In addition, the suggestion that natural selection could have gradually built a flagellum by co-opting parts from other systems didn't make sense.
It is graphically convincing, but if you know the ontogenesis of the flagellum motor, then it is completely ridiculous. It cannot work. You cannot build the flagellum by just adding outside of the cell wall some protein elements on it and make the flagellum longer and longer. This kind of scenario doesn't make sense in terms of the ontogenesis of the structure.
Like Behe a couple of decades earlier, Beckley began to dig deeper.
And so when I read those books on intelligent design and the books by Mike Behe and Bill Dembski and the book by Steve Meyer were not existing then. I thought there is some merit to it, and I made contact with some of the representatives of the intelligent design movement. The next thing I found out is that they are much different from what I expected. They're open-minded. They're not religious fanatics who try to push a kind of theocratic system onto society under the label of intelligent design. They are really interested, is this neo-Darwinian story really true, or is there scientific reason to doubt it?
Beckley didn't fit the usual stereotypes of a Darwin skeptic.
So many people will think somebody who comes to doubt the neo-Darwinian process and embraces intelligent design probably was religious from the very beginning, probably is an evangelical Christian and has his axe to grind, his religious axe to grind. I came via a totally different path to the views I hold now. I'm coming from a family background which is totally secular, agnostic, was not baptized, didn't join any kind of religious education, never went to church, so I was completely irreligious. Was not even interested for most of my life in philosophical or metaphysical questions. I was interested in nature, in animals, and in natural sciences.
Beckley publicly disclosed his support for intelligent design for the first time in 2015. As Beckley was thinking through his doubts about Darwin in Germany, an American scientist was conducting lab experiments that would expose just how daunting the challenges facing Darwinian explanations really are. Douglas Axe earned his PhD at Caltech. He then spent 14 years doing research in molecular biology at top labs in and around Cambridge University. Axe was skeptical of Darwinian evolution, and he wanted to find ways to actually test what it could and couldn't do. When Axe returned to America, he formed Biologic Institute to do just that. Axe doesn't work on the bacterial flagellum, but he and his colleagues, Ann Gager and Marcy Reeves, have conducted experiments that help address the feasibility of Darwinian explanations of the flagellum. Those explanations depend on the idea that natural selection can easily reuse existing parts and adapt them for new functions. But Axe's experiments raise two problems for this and other Darwinian claims.
I refer to these as the big problem and the little problem. One is the big problem of inventing an entirely new protein structure to do something new. And the smaller problem is tweaking an existing structure so that it does something slightly different. Clearly, one of these is more challenging than the other. And my work early on showed that the bigger problem was beyond the reach of evolution. You have to get too much right in order to get a new structure to form, in order for accidental causes to get these new structures. So my colleagues and I, Ann Gager in particular, started to look at the smaller problem, which is, can you take an existing folded structure and evolve a new function for it? And somewhat surprisingly, we found that even this smaller problem is too hard for Darwinian evolution. At least in the cases that we've examined, the number of changes you have to make to an existing structure to get a new function to be performed by it is beyond what you can get by random mutation, by Darwinian evolution.
Critics of Behe had suggested that natural selection could build complex new machines such as the flagellum by co-opting simpler molecular machines made up of several protein parts. But Axe's research seemed to show that co-opting even one existing protein to perform a slightly new function was beyond the reach of the Darwinian mechanism. After Dover, Behe published a new book that helped explain why. Behe showed that building many complex biological structures and even new proteins would likely require multiple coordinated mutations.
Many different biological processes will require multiple mutations before they're going to have an effect.
But according to Behe, new studies in population genetics showed that coordinated mutations were beyond the reach of natural selection in many cases.
Long and the short is that if you need more than one thing to happen at a time, the improbability of getting the correct two mutations goes up exponentially. If you need to change one particular subunit of DNA, well, there's 3 billion subunits in a mammalian cell. So the odds, if you need one particular one, that's, well, 1 in 3 billion. Okay, well, that sounds like a lot, but there might be billions of organisms around, or at least over time. But if you need 2, that means you need 1 in 3 billion times 1 in 3 billion. It goes up exponentially. You have to multiply them together. And so you very quickly run out of probability.
Behe's analysis helped explain why a growing number of lab experiments have demonstrated the limits of the mutation natural selection mechanism. Since the late 1980s, Michigan State University biologist Richard Lenski has been running a long-term evolution experiment with E. coli bacteria. A staunch supporter of Darwinian evolution, Lenski wanted to follow a population of bacteria over time and see what new functions would evolve.
I'm a big fan of this experiment because it does not put out a model, it's not a computer model, it's not a theory. What he did was let evolution happen on its own and say, what did it do?
By 2014, Lenski and his researchers had grown over 60,000 generations of bacteria.
That's equivalent to, say, a million years in the lifespan of a large animal like us. And there have been trillions upon trillions of different bacteria that have been born and died in his flasks.
Although often cited as providing evidence for Darwin's theory, Lenski's experiments are perhaps most revealing in what they haven't produced.
We don't find a new protein with a new fold with a new function. By and large, these are deletions, insertions, rearrangements of information that's already present.
He didn't see anything like the evolution of some new complex system like the flagellum. Nothing remotely like that.
At some point, you're going to have to show that you have a gene with one function has now evolved into a gene with a different function, different protein folds, and we're still waiting.
What we see going on in the Lenski laboratory and other places too is that Darwinian processes or random processes degrade information. They do not build it, they are not putting in new information. They might tweak something here or there, and at the margins you can have differences about what you call information.
Taken together, this flood of new data has raised a powerful challenge to claims that natural selection can explain the origin of new functional genes and proteins, let alone a complex biological machine like the flagellum. At the same time, new hurdles to the Darwinian mechanism are also being raised that are specific to evolutionary accounts of the flagellum itself. For example, evidence has continued to accumulate that the type 3 secretion needle complex was not a precursor to the flagellum after all.
The flagellum definitely came first.
Mutation density studies show that genes in bacterial flagella have experienced more mutations than genes in type 3 secretion needle complexes. Genes that have experienced more mutations are generally presumed to be older.
We find flagella across all phyla of eubacteria, very deep. The mutational densities are great for bacterial flagella. We find them arranged in the same genetic arrangements on the chromosome across genera, across families. For the most part, there's been some rearrangement. It was part of the aboriginal chromosome of these organisms. In contrast, type 3 secretory systems, we find in a very narrow range of gram-negative bacteria. They've been imported, and the mutational densities are much shallower, which means they're newer structures compared to the flagella.
The supposed killer explanation against Behe has turned out to be a dud. The needle complex can't explain the evolution of the flagellum because it didn't even exist until after the flagellum. But there's more. Darwinian explanations of the flagellum assume that parts already existed that natural selection could reuse in order to build the flagellum. This may well explain some features of the flagellum, but there's a big problem. Key flagella parts are turning out to be unique. They don't appear to exist anywhere else. they are only found in the flagellum, and if they didn't exist already, natural selection wouldn't be able to use them to build something else. Even if all the necessary parts were there for natural selection to co-opt, it's now becoming evident that just having the parts alone wouldn't be sufficient. Complex structures almost always require a specific sequence of assembly. When building a house, a foundation must be laid before the frame can be put up, and the frame must be completed before the roof can be added. In a similar way, a flagellum must be built in a carefully orchestrated process that is governed by assembly instructions encoded in the DNA. Merely having the various parts of the flagellum available in the vicinity of a bacterium isn't enough.
Even if you had just floating around a type 3 secretory system or a hook protein or a rotor or a drive shaft, you've got to put these things together. And biological systems aren't put together like Lego bricks. You don't just stick them together. There's a very precise sequence of expression of these genes, these protein products, that allows the machine to be built piece by piece, somewhat like the assembly apparatus in an automobile factory. That assembly routine involving multiple different genes and regulatory proteins is itself arguably an irreducibly complex system. You remove any one of those genes or one of those regulatory proteins, the flagellum is simply not going to get built. Something will shut down the biosynthetic pathway if one of those key elements is missing. So co-option in an attempt to get around the irreducible complexity of the finished product posits a bunch of parts which could only be plausibly put together by another irreducibly complex system, so you haven't really solved the problem.
The existence of assembly instructions required to build a flagellum isn't simply a challenge to Darwinian evolution. It also provides evidence of intelligent design. Encoding the assembly instructions requires massive amounts of biological information. But where does that biological information come from?
The genome is full of information. It has literally a sequence of DNA letters which tell the machinery of the cell what to make. It's like a blueprint.
We know of a cause that can produce digital code, hierarchically organized information, integrated circuitry, and that cause is intelligence. In fact, that's the only known cause that we know of based on our uniform and repeated experience, the basis of all scientific reasoning about the past, that we do know of that can produce information, and therefore it is possible to infer from those effects information processing circuitry back to intelligence as the best causal explanation of those complex molecular machines.
More than 2 decades after the publication of Darwin's Black Box, the challenges to Darwinian explanations of molecular machines like the flagellum have become even more daunting. As a result, evolutionary biologists are scrambling to find new unguided mechanisms in order to avoid facing the alternative proposed by Behe and others, that biological systems reflect intelligent design. Michael Behe raised ideas that even now are reshaping how we understand biological systems. The man who describes himself as shy helped spark a revolution.
Well, one of the things I like about Mike Behe is that he's a very humble and unassuming guy. He's not full of himself, yet he's a player on the world stage scientifically. People all over the world know of his idea of irreducible complexity. They know of the idea of intelligent design because of his work. And it's really reframed the debate. Whether you agree or disagree, one way or another, you've got to now address the question of the origin of these irreducibly complex systems that we find in living systems, whether we're talking about the flagellar motor, or the ATP synthase, or the kinesin walking motor protein, or the circuitry, or the gene expression system, or whatever it is. The biology inside the box is really complex, and it's an integrated and functional complexity that requires some kind of an explanation. And I think just by highlighting that, Mike has reframed the debate in a way that I think has changed the way people think about biology in the 21st century.
For Behe, the most satisfying part of his intellectual journey isn't getting recognition, it's opening minds.
I remember in particular a time I was talking at the University of Massachusetts at Amherst, and also on the stage and also talking, it was not really a debate, but a kind of a different perspectives on issues, was a lady named Lynn Margulis, who was a very prominent biologist, a member of the National Academy of Sciences. And there were about 1,000 students in the audience. There was reporters from the New York Times, the president of the university was there. It was great. And after discussing it, I had a number of students come up saying exactly that they hadn't thought about it from this perspective before. They thought either that you had to be for evolution, you know, quote unquote, or for creation, quote unquote, or that, you know, you couldn't have scientific reasons for being skeptical of Darwin's theory. And they kind of scratch their heads and say, yeah, I'll have to think about that. And that's the moments that a teacher like myself just lives for.
Get ready for the revolution. It's coming to you now. It's coming to you now. Rising up, now the tide's turning. Feel the heat, yeah, the fire's burning. No hesitation, our generation leads us onward. Start the clock, now the game's changing. Curtains up and the lights are blazing. We're never gonna turn this dream around. Get ready for the revolution. It's coming to you now. It's coming to you now. You're witnessing an evolution. And they'll never bring us down. No, they'll never bring us down. Feel the rush and the race is on, yeah. Turn it up, it's your favorite song, yeah. Our motivation, our inspiration feeds the fire. There's a light on a new horizon. There's a dream that our hopes are guiding. And this time we're gonna reach the other side. Are you ready for the revolution? It's coming to you now. It's coming to you now. We're witnessing an evolution. And they'll never bring us down. No, they'll never bring us down. Get ready for the revolution. It's coming to you now. It's coming to you now. You're witnessing an evolution. And they'll never bring us down. No, they'll never bring us down. Get ready for the revolution. It's coming to you now. It's coming to you now. You're witnessing an evolution. And they'll never bring us down. No, they'll never bring us down. Get ready for the revolution.